Hi there and welcome to this video for Senior Physics on Electromagnetism and Electricity. In this video we're going to be looking at the magnetic fields which are generated in solenoids using the PhET simulation. Now I've basically got the PhET link here, but I'll also put it in the post so that you can download the link and have a play yourself. Okay, so let's get started and have a look at what we can find using the simulation. Alrighty, so here we've got our simulation all set up, and you need to click onto the electromagnet section of the unit. Now what I've done is using the right hand side here, I'll just close it down just a wee bit so that I can put it all in. That's better. Okay, we can see that we can determine our power source over on the right hand side. So in this case I've got a battery and I'm going to be using direct current or DC. We could also have a look at using AC, which I'll have a look at later on. Now, you can determine your fields, so you can show your fields, you can show your compass, you can put a field meter in there, and you can also show your electrons. Now, at the moment, I've got my battery set to 0 volts. That means 0 joules per coulomb or per unit of charge is flowing. Down here, we can see the loop, and the balls that we can see are basically the electrons. Here is the magnetic field meter, and I've also got a compass to show the idea of field. So at 0 volts we've got no movement. No moving charge means no magnetic field. So if you relate that back to our initial statement that we talked about in earlier videos, that will make sense. Now what I can do is then start increasing the amount of energy which is given to the electrons. As a result, I've got 3 volts here, so that's 3 joules of energy given to every unit of charge. Now you can see here that the electrons are moving round. Okay, as they move round, you can see that they're moving from negative through to positive. We can see that if I use my compass, you can see there that the compass is attracted to the movement. Now, if you remember what we worked on, we said that basically we're going to get north as it moves round. We're going to get north coming out at this end here, and this is going to be the southern end here. Now if I move my compass round, you can see how it all links together. So there's our magnetic field which has been generated by the solenoid. Now let's have a look at the meter. So we're going to pull the meter in here. I'm going to pull it in around about this point here. Doesn't really matter where I put it, but it's just there to actually show what happens when we increase the number of loops. Now we can see that the field is reading 22.5. So what happens if I increase the number of loops? Now, we'll work on loops first. If I increase the number of loops, you can see that there's one loop. Put a second loop in and it's doubled. Put a third loop in, it's increased by the same amount, and put a fourth loop in and we've gone up to a magnetic field strength of 90 at this same position. If I move over to the other side, you'll see that it's exactly the same. The further away I move, you can see that the field has gradually got weaker and weaker and weaker. So again, that backs up the theory that we looked at earlier in the course. Now obviously I don't have to increase the loops. I could also increase the amount of energy which is flowing from the battery. So I'll put it back here, 22.5 is my magnetic field strength. What happens if I decrease the voltage? Well, if I decrease the voltage, I've now decreased my magnetic field strength. We can go down again, there's 7.5. So it's going up in equal increments. So 7.5 per voltage, 15, 22.5, 30, and so forth and so on, right up to 10, okay, where I'm getting 75, a magnetic field strength equal to 75. And as I move around, basically we will get varying field strengths depending on the position that we happen to be as we move around the solenoid. Okay, see 75 there, 75 there. So that makes sense. Now obviously increasing the voltage here, you can see the speed at which the electrons are moving. Well, the speed at which the electrons are moving is the amount of charge per second. That's the current. Increasing the current isn't always a good idea. So basically what we've got is this idea that if I increase the number of loops, look how the magnetic field increases down the bottom here. We've gone from, what was it, we've got a 75, increase up to 4, we've gone up to 300, a field strength, magnetic field strength of 300. Now obviously if I then decrease my voltage, I'm going to decrease my field strength, okay, and you can see even at 1 volt now I've got 30, okay, a magnetic field strength of 30. Now what happens if I go in the opposite direction? Well, I get to 0, all the field is cut off because there's no moving charge. So what happens if I move in the opposite direction? Well, all that happens is the magnetic field changes direction. Okay, so instead of having the red arrow pointing on the left-hand side, I've now got the white arrow. Okay, I'll just move that to the side, and that will allow me to move my compass needle around, and you can see red is coming in here. And now what we've got is the north. If we use our grip rule again, our north is going to be coming out to the right-hand side of that solenoid. Does it apply? Do we get the same sort of situation if we increase the voltage? Well, let's see. Let's put our crosshairs there. So we're on 1 volt, which is 30. Let's put it up to 10. Should be 300, and there we go. There's our 300. So you can see the same laws apply on both sides. Okay, so we can play with this and basically see what's actually happening. Now, what's also interesting is we can now have a look at what happens with AC. Now, although we haven't looked at AC so far in this unit, AC is alternating current. And in the West, alternating current flips over 50 times per second. So what that means is the electrons is flowing in one direction for a 50th of a second, then it flips over and goes in the opposite direction for a 50th of a second. So obviously at 0 volts, we're going to should have 0 current acting, but so that would be down, it doesn't go down to 0, but basically what I can do is increase from a 5% supply, getting gradually stronger and stronger and stronger. Okay, now what you can see there is as it moves, can you see how, let's put the magnetic field here, we're flicking between around about 140 in each direction. You can see that the compass needle is flicking between going in one direction then going 180 degrees in the opposite direction. This is directly related to the sine curve. As we go in the positive direction, we go down into the negative direction. As we start from 0, we'll go right up to its maximum of 140, and then we'll drop down to 0, and then we'll go down to negative 140 and back again. So we get a similar sort of process which is occurring, except all we're doing is flipping between the two terminals. And all that does is change the polarity of our solenoid. So I hope you found that useful. Do have a go and play with it. It's a fantastic simulation to really get you to understand exactly what's working. So thank you for joining me, and I look forward to you meeting me again. Thanks for watching.